In this video, we'll use factorial, double factorial, and gamma to generate the Thermochlorine series sum of the arcsine function. We begin with the data set of the arcsine function. Array formula, arcsine of the x values from negative zero point 0.8 to positive zero point 0.8. And we'll chart this. Insert chart, and we'll use scatter chart. We show the trend line, series, trend line, polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. For the horizontal axis, the number format, none. For the vertical axis, show the axis line. And the number format, none. Now that's better. So here's the trend line and polynomial to the 8th degree of the arcsine function. Next, we continue with the Thermochlorine series sum, which is the summation of a times x to the power 2n plus 1, where a, the coefficient, can be factorial, double factorial, or gamma, and the value of n is from 0 to infinity. And since this is only an approximation, 16 is good enough for infinity. And we continue with the gamma function. So array formula of that's gamma n plus 0.5. So n plus 0.5 divided by, there are three parts. The first part, the quantity 2n plus 1, 2 times n plus 1. The second part, factorial n, factorial n. The third part, square root of pi, square root of pi. That's square root of pi. And we continue with the double factorial, which is equal to array formula. That's double factorial. So double factorial 2n minus 1. So 2 times n minus 1 divided by, there are two parts. The first part, double factorial, that's double factorial 2n, 2 times n. And the second part of the denominator times the quantity 2n plus 1. So 2 times n plus 1. And enter. Their values are exactly the same up to this portion, but we'll correct this. So if n is 0, it should be 1. So we'll correct this. So if n equals 0, then it's 1. Otherwise, calculate. Now it's corrected. Now we continue with the factorial form, which is array formula. The numerator, factorial 2 times n. That's factorial 2n. That's the numerator. Now the denominator, there are three parts. The first part, the quantity 2n plus 1. 2 times n plus 1. The second part. The second part is the quantity 2 to the power n times factorial n squared. So the first part is 2 to the power n times factorial n. And the whole quantity raised to the power 2. That's squared. That's 2 to the power n times factorial n and raised to the power 2. Then enter. Their values are exactly the same. Now we continue with the expansion. So array formula, series sum of the x values raised to the power 2n plus 1. 2n plus 1 starts from at n equals 0, that's 1. 1. Followed by 2 times 1 plus 1, 3. 2 times 2 plus 1, 5. 2 times 3 plus 1, 7. So 1, 3, 5, 7, 9. The increment is 2. And the coefficient, any of the three. So we'll choose the first one, the factorial. Then enter. And we show the trend line and polynomial. So that series, trend line, polynomial to the 8th degree, and the label, use the equation. So here we have the polynomial to the 8th degree and the trend line. They're all the same, the polynomials are the same. We'll calculate this polynomial regression coefficient using the Linest function, starting with the Linest matrix. So transpose 0 to 8. And the elements of that Linest matrix. So this is equal to array formula of the x values raised to the power 0 to 8. Now that we have the Linest matrix, we can now calculate the polynomial regression coefficient using Linest data y for the arcsine function itself and data x. And the expansion, which is Linest data y and data x. And enter. Let's compare. So the coefficient of x to the 0, 0. Coefficient of x, 1. Coefficient of x squared, 0. Coefficient of x cubed, 0.172. Coefficient x to the 4th, 0.0361. X to the 4th is 0. Coefficient of x to the 5th, 0.0361. X to the 6th, 0. Coefficient of x to the 7th, 0.132. Coefficient of x to the 8th, 0. Suppose I change this, instead of using the factorial, I will use the double factorial. Let's see what happens. The polynomial regression coefficients are still the same. The polynomials are the same. The trend line is still collinear. And the datasets are still the same. If I use the gamma form, so replace this with gamma. This is the gamma form. Then enter. Still, the polynomial regression coefficients are the same. The polynomials are the same. The trend lines are still collinear. And the datasets, they are still the same. This completes the use of factorial, double factorial, and gamma as expansion coefficients of the Taylor-Maclaurin series sum expansion of arcs